I'm Allegra.
And I'm Juan.
And we're the Jaded Juniors.
Initially, when we were creating our monitor, what we wanted to make was a quote-unquote objective monitor, which would display actual metrics such as decibels in sound, temperature in Fahrenheit, and actual percentages in humidity. But then we realized that all we were really concerned with was determining the comfort of the environment for a student so that there would be no purpose in displaying absolute quantities. For that reason, we moved towards a quote-unquote subjective monitor, which would just detect changes with respect to a certain threshold that the student would be able to set, which resulted in this current model with a calibration mode and a monitoring mode, and our binary display with LEDs. The brain of our project is our Arduino Uno microcontroller, which is constantly listening to the input from sensors. When it's in calibration mode, which it reads off from this switch, it looks at a particular sensor and captures what it's currently reading. So for example, if I cover the light sensor, then it'll be reading less light, and if I take my finger off of it, then it'll be reading more light. And if I press the button, the Arduino will notice that and switch the light that it is driving, and also switch the sensor whose threshold it is currently setting. Then, when I go into sensing mode, the Arduino iterates through each sensor, constantly monitoring the value that it's currently at and comparing it to the threshold it was set to. When it detects that a sensor has exited the desired threshold, then it triggers the LEDs, and when it senses that it goes back to the desired threshold, then it turns the LED off. This blue vented sensor is the DHT11 temperature and humidity sensor. It produces digital output, and to interface with it, we downloaded the DHT-XX Adafruit sensor library in order to be able to read its output from our Arduino.
To sense light, we used a photoresistor, and so you give it voltage on this end, and then on the other end we used a voltage divider. And given that this is a resistor, as the resistance changes, so does the voltage going into the analog input of the Arduino.
In order to monitor sound, we use a SparkFun sound detector, which as you can see is currently detecting my voice. It has this microphone here which takes in sound and then produces various outputs. We are reading from envelope, which produces a voltage wave of the sound that it is taking in, and then detect and take it in as an analog input to our Arduino.
We made an environment monitor that senses for the light, temperature, humidity, and sound levels of a certain space. And so if you have it in calibration mode, which is on the side of the switch, you can calibrate each sensor. So right now you're calibrating light, temperature, humidity, and sound. You can also adjust the sensitivity of your sensors. Turning the knob this way will make it more sensitive. Turning it that way will make it less sensitive. And then when you flip the switch from calibration mode to sensing mode, you sense any differences in the environment. So for example, if I make the environment darker, the light switch LED will trigger, or if I speak into the sound sensor, the sound light will trigger. If you blow into the humidity monitor, humidity will trigger, and that's the project. We out here braving the elements in the name of lab. We're all very happy about it.